a star on a collision course with our solar system. It is hurtling towards us right now, and scientists fear that it could cause destruction and chaos. Find out in this video whether we have to worry, so be sure to stay tuned until the end. And if you like it, I'd be thrilled to see a thumbs up because that will make this video even more people. Thank you friends, and welcome. I'll even go and get the stars for you folks, but in this case, it's more of a threat because one of our neighboring stars within the Milky Way is going to come dangerously close to us and potentially even endanger life on Earth. Sounds like a science fiction story from a bad movie, but it's bitter reality. But let's take it one step at a time. I can already hear some of you saying angrily,
"Stars can't get too close to us. They have their fixed place in the Milky Way."
It is basically true that stars have their position within the galaxy and participate in the galactic movement with this position. Our solar system, for example, sits on one of the outer spiral arms of the galaxy, and we orbit the galactic center together with the other stars. Such a revolution takes about 225 million years and is called a galactic year. So right now, we are not only racing around the sun with the Earth, but also with the solar system through the galaxy, an incredible thought. And of course, the other stars are also wandering through the Milky Way in the same way, but these stellar positions are not completely fixed. Each star also has a certain amount of movement of its own. This can lead to slight variations in the distances between the star systems over very long periods of time. However, this does not usually lead to collisions. Stars are very polite, respect the privacy of other suns, and do not get in each other's way. Some people could learn a thing or two from them, but then, just like with us humans, there are some who always have to get under other people's skin, like the people who hold their smelly armpits in your face on the subway. One such star is Gliese 710, which moves completely independently of the other stars and does not participate in their galactic rhythm around the center of the Milky Way. Such stars are called rogue stars or wandering stars. There are two types of rogue stars, intergalactic and intergalactic rogue stars. The intergalactic ones are still in a galaxy, but they just ignore the galactic year and fly around as they please. The intergalactic ones have even left their galaxy and are now drifting completely lost in the black emptiness of the cosmos, far from any galaxy. It's a bit like the armpit guy from the subway who flew out and is now an inter-subway armpit sweater. What am I talking about here? Gliese 710 has not yet suffered such a fate as an outcast. It is still in the Milky Way, which is bad for us because it is racing towards us. In cosmic terms, it will soon be marauding through our solar system, and if you're now shouting,
"That's not true, it's clickbait,"
let me tell you, it is true. In a research paper on the subject by Philip Bursky and Piotr Dybczynski, it says, "This event will be the most disruptive event in the future and past of the solar system. We can expect this star to have the strongest influence on the Oort cloud in the next 10 million years. So what exactly will happen? The researchers have calculated that Gliese will hit our solar system in 1.25 million years. That's nothing on a cosmic scale. It's practically the blink of an eye. By way of comparison, the Earth has existed for almost 4.5 billion years, and the Gliese event will take place in less than 1.5 million years. Fortunately, Gliese will not crash into the solar system head-on, but will crash into the outer regions, namely the Oort cloud. This is a distant area that represents the last frontier of the solar system. Here, the sun's gravity is just strong enough to keep objects such as comets and dust particles in its orbit. The Oort cloud has not yet been proven beyond doubt, but that is only because our technical means are currently too poor to see it, because we are talking about the smallest particles and pebbles that are incredibly far away. Some researchers suspect that the Oort cloud could extend over a light year. Even if the Oort cloud has not yet been seen with a telescope, it must exist. Because at some point there must be a boundary where the sun's gravity slowly loses the upper hand and the gravity of other stars within the Milky Way becomes stronger. And it is precisely at this border that spheroidal objects must be arranged around our solar system. Gliese will maneuver into this collection of comets and asteroids and will not only hit the most distant outer regions of the Oort cloud. According to the latest calculations, it would pay us an unwanted visit at a distance of just 62 light days. That is still far away by human standards, but from a cosmic perspective, it has to be said that it will race through our solar system 100%. I have simulated what it will look like for you here. You can see here how Gliese passes by the inner solar system. However, the area in which it is located is an integral part of the solar system itself. From Earth, it will of course be a spectacular sight. Gliese will be clearly visible in the sky, brighter than the large planets Jupiter and Saturn, and it will even be visible in the sky during the day. If you are an amateur astronomer, you can look forward to it, at least if you plan to live for another 1,000,000 years. But now the big question is, how dangerous is it? Gliese's flyby itself will probably not endanger life on Earth. There will be no changes in gravity that would throw the planetary orbits out of whack. But now comes the big but. Gliese will cause chaos and devastation in the Oort cloud. It will throw a lot of asteroids and comets out of their orbits and hurl them in the direction of the inner solar system. It is expected that it will create at least 10 new long-period comets visible from Earth every year. But it is also entirely conceivable that Gliese will send some chunks on a collision course with the Earth. In their work, the researchers assume that the frequency of impacts on Earth will increase by at least 5%. Since we do not know exactly how large the chunks will be, the probability of a planet-destroying impact also increases significantly. Here I have simulated the impact of such a chunk from the Oort cloud. Of course, we still need an appropriate name for this planet killer. Write me your suggestions in the comments. What should I call this giant asteroid? But guys, you don't have to lose any sleep over it. There is someone who will save us, and unfortunately, it's not Bruce Willis. It's NASA, because in the face of this Gliese horror news, it's very convenient that NASA has tested exactly such a scenario with its DART project. It rammed the poor little asteroid Dimorphos with a probe, while another little sun recorded exactly how big the orbit deflection caused by the collision was. This was an important step in the defense against future dangerous asteroids, because now we know how to hit an asteroid to change its orbit to a certain extent. And I would guess that our asteroid ramming skills will be even better in a million years when Gliese says hello to us, so it could get a bit bumpy and dangerous, but I think we humans will somehow manage. And of course, you can be sure that in 1.2 million years there will be a YouTube video of me about it. Such events could also have happened in the past of the Earth long before mankind existed, and that is an exciting addition to the so-called Silurian hypothesis, according to which there could have been an alien advanced civilization on Earth, but it was then wiped out, maybe by a passing star. Whether there really was another intelligent species on Earth and whether we can find any traces of it, you can find out in the video below. Be sure to check it out. And if you want to support my work, then take a look at the older videos on the channel. There are many more exciting topics to discover. Otherwise, I'd say see you in the next video. Take care, friends.